My name is Javier Rodriguez, and for today we'll be discussing one of the problems from our Physics 2 test number 3, which goes over EMF, basic circuit analyzation, magnetic forces, and a couple other concepts. So the problem that cost me the most difficult in my opinion was the first problem, where we were shown a circuit with two batteries that was connected to 3 bulbs in this way. There was a regular bulb here, a bulb with a different resistance here, connected to another regular bulb over here. So this is a classic node rule and loop rule problem. So for this specific problem, we can see that we're going to actually have 3 loop rules. So the first loop rule is outside, as you can see. The second loop rule was actually also outside, but instead takes the inner path. So it's slightly different. And our final loop rule equation is inside here, where the potential difference will end up being 0, because we know that for any full path, the potential in a circuit, the potential difference is actually 0. So now that we know that, we can actually start writing down our loop rules. So let's take care of this. So we know that the delta V of the battery should be equal, in the first loop, the outside one, should be equal to the potential, should be equal to the negative potential difference from the regular bulb plus the potential difference, minus the potential difference of the other regular bulb. So we know that if we actually add both of those together, so we know that the final loop rule for the outside loop would actually look like 2 EMF, which is the delta V of the battery, minus IR for the outside battery, minus IR for the other battery, which has the same resistance but not necessarily the same current, is equal to 0. So now for our second loop rule equation, we know that, which is the inside one, between the 2 different resistance bulbs, we know that all we have is the delta V of one of the bulbs plus the delta V of the other bulb, which is equal to 0. So we know that in actuality, IR of the regular bulb, which is the same thing we had in our last equation, is actually equal to IR of the bulb with a different resistance, which has I3 and RO. It has a different resistance from the other 2. And now our final loop rule equation is actually going to be the one that's outside but takes an inside path instead of the outside one here. So it's going to look like this. So for that one, we have once again a delta V of the battery, which is the 2 batteries, plus the delta V of our outside battery, our outside bulb, delta V of bulb, plus the delta V of the bulb with a different resistance. So we can denote it with something else, is equal to 0. Expanding on this, we have that 2 EMF minus I1R, which is the delta V for the outside battery. It's actually, and then minus I2R, which is the delta V of the battery with the different resistance, different R, is equal to 0. So now with our 3 loop rule equations, we need the node rule equations in order to actually quantify them and start solving for what we want. So here, the only important node rule that we need to know is that in this particular part right here, we have 3 bulbs. If we count this as I1, and this is I2, and this is I3, then we know I1 is actually going to be equal to I2 plus I3, because what's going in is going to be the same thing that's coming out. So there we go. Now we can relate all of them together and actually solve for the potential difference. Actually solve for the conventional current and the resistance of our oblong battery, of our oblong bulb, which has a different resistance than the other 2 bulbs. So we know that I2R, which is one of our regular batteries, is equal to I3RO, which is the battery inside with a different resistance. So that's where you see the different subscript on the battery. And using our equations up top, we know that I2 is actually going to be equal to EMF over IR, which is the resistance for a regular battery, right? Because this is the value of the resistance that we found earlier. And that's actually going to be equal to I3 times EMF over IO, which is what we're trying to find, because this is the conventional current going through the bulb with different resistance. Therefore, we know that I2, conventional current going through the outside bulb, is equal to I3 IR times IO, where these two things, where this is known. So expanding through that, we will end up finding that I3 is actually going to be equal to IR IO over IR times IO, where this should be our final result. Because you're trying to find where we factor out the EMF, because the EMF is actually unknown, and we want to put it in terms of things that we already know. So thanks for attending this Physics 2 Wrapper. I hope you learned something, and hopefully you'll be able to put it to good use for your tests, whether it's at Georgia Tech or somewhere else. Thank you for your time, and have a nice day.